Imagine creating the equations that changed humanity's understanding of space and time, but history remembers someone else more than you. Without Hendrik Antoon Lorentz, Einstein's theory of relativity might never have existed. Today, we explore the life of the quiet genius who made time slow down and length shrink, at least mathematically. This is the story of the man behind relativity. Hendrik Antoon Lorentz was born in 1853 in Arnhem, Netherlands. From a young age, he displayed extraordinary talent in mathematics and physics. His intelligence and dedication quickly set him apart. By the age of just 24, Lorentz became a professor at Leiden University, an exceptional achievement in the 19th century. At that time, physics was undergoing a transformation. Scientists were deeply engaged in understanding electricity, magnetism, and light. James Clerk Maxwell had already introduced his famous equations, showing that light is an electromagnetic wave. This discovery was revolutionary, but it created a serious problem. Waves usually travel through something. Sound travels through air. Water waves travel through water. So if light is a wave, what is it traveling through? Scientists believed there must be an invisible medium filling all of space. They called it the luminiferous ether. This mysterious ether was assumed to be everywhere, even in a vacuum. Lorentz dedicated much of his early career to mathematically explaining how light moved through this ether. While working on electromagnetic theory, Lorentz developed ideas about tiny charged particles inside atoms. These particles would later be known as electrons. His electron theory helped explain how electromagnetic waves interact with matter. This was a major step forward in understanding atomic structure and laid groundwork for future developments in quantum physics. Lorentz was not just refining existing theories, he was building a bridge toward modern physics. Then, in 1887, something happened that shook the scientific world. Two American scientists, Albert Michelson and Edward Morley, conducted an experiment to detect Earth's motion through the ether. If the ether existed, the speed of light should vary depending on the direction of Earth's movement. They designed a highly sensitive instrument to measure these differences. The expectation was clear: they would detect an ether wind as Earth moved through space. But the experiment produced a shocking result. They found no difference in the speed of light. No ether wind, no detectable motion through any medium. The speed of light appeared to remain constant in every direction. This result contradicted the very foundation of ether theory. Physics faced a crisis. If ether existed, why couldn't it be detected? Lorentz refused to ignore the problem. Instead, he searched for a mathematical explanation. He proposed a bold and unusual idea. What if objects physically contract in the direction of their motion? This contraction would be so small that it would only become noticeable at extremely high speeds. This idea became known as length contraction. To support this concept and preserve Maxwell's equations, Lorentz developed a set of mathematical formulas. These formulas would later be called the Lorentz transformations. The Lorentz transformations revealed something astonishing. They showed that when an object moves close to the speed of light, time itself slows down for that object. Length contracts along the direction of motion. Even mass increases with speed. Space and time were no longer fixed and absolute. They depended on motion. These equations worked perfectly to explain the Michelson-Morley experiment. However, Lorentz still believed the ether existed. He thought these effects were physical changes caused by moving through the ether. Then, in 1905, a young patent clerk named Albert Einstein published a paper that would change everything. In his special theory of relativity, Einstein used the same mathematical transformations that Lorentz had developed. But Einstein made one radical decision: he eliminated the ether entirely. Instead of saying that objects change because they move through an invisible medium, Einstein proposed a new principle: the speed of light is constant for all observers, regardless of their motion. From this single idea, the relativity of space and time naturally followed. The mathematics remained Lorentz's, but Einstein's interpretation was revolutionary. He reframed the understanding of reality itself. Space and time were not distorted because of ether. They were fundamentally interconnected and relative. Einstein later acknowledged Lorentz's enormous contribution and held him in the highest respect. In fact, Lorentz and Einstein corresponded frequently, and Einstein admired him deeply. Lorentz's contributions did not go unnoticed during his lifetime. In 1902, he won the Nobel Prize in Physics along with Peter Zeeman for the discovery of the Zeeman effect, which demonstrated how magnetic fields influence light emission. This discovery provided further confirmation of the electron theory and strengthened the link between electromagnetism and atomic physics. Lorentz was widely respected not only for his scientific brilliance but also for his humility and generosity. He was known as a kind mentor and a clear thinker. Scientists across Europe admired him. When Lorentz passed away in 1928, the Netherlands declared a national day of mourning. Government buildings lowered their flags. Thousands of people attended his funeral. Albert Einstein traveled to pay his respects. This was not just a tribute to a scientist, it was recognition of a man who had reshaped the foundations of physics. Today, Lorentz's influence is everywhere. The Lorentz transformations remain central to modern physics. Particle accelerators rely on relativistic equations to calculate the behavior of high-speed particles. Quantum field theory incorporates Lorentz symmetry as a fundamental principle. Even the GPS system in your smartphone must account for time dilation effects predicted by relativity. Without adjusting for these relativistic effects, GPS calculations would quickly become inaccurate. Every time you use navigation on your phone, you are benefiting from the mathematics Lorentz helped develop. His work forms part of the invisible structure of modern science. While Einstein became the symbol of relativity, Lorentz provided much of the mathematical framework that made it possible. History often celebrates the bold revolutionary, but it is equally shaped by those who quietly construct the foundation. Hendrik Lorentz was one of those foundational figures. He did not seek fame. He pursued understanding. He gave physics the tools to move beyond classical limitations and into the modern age. He helped transform abstract equations into a new vision of reality, one where time is not universal, where length is not fixed, and where motion shapes measurement itself. Time may be relative, length may contract, but Lorentz's contribution to science remains constant. His legacy lives on in every equation describing high-speed motion, in every satellite orbiting Earth, and in every student learning the fundamentals of modern physics. Behind every great scientific revolution, there are minds that build the structure before the spotlight arrives. Hendrik Antoon Lorentz was one of those minds, the architect behind relativity, the mathematician who quietly redefined space and time.